This next topic is pretty complicated for some people. It gets into the physics principle of work. And work is a very complicated concept in physics. If you remember from the MCAT, work is defined as force times distance. And that kind of doesn't make a lot of sense sometimes when you think about it, because let's say there's a brick wall and you push on that brick wall and it doesn't go anywhere. Did you do any work? No, you didn't. But you're going to say to yourself, I put in a lot of force and I was working. It doesn't make any sense. Well, the problem is that when you're pushing on that brick wall, there was an equal and opposite force pushing back at you. And so the net force was zero. So that's why there was no work done, is because we're really talking about the net force. Okay, so let's go ahead and apply that to the left ventricle once again. And so when we talk about the left ventricle, we want to talk about stroke work. And stroke work is going to be estimated to be mean arterial pressure divided by multiplied by stroke volume. So if we look at our generic flow volume loop again, so we have our flow volume loop. The area inside this loop is actually stroke work. But because of how these things are curved and whatnot, it's not really possible or practical to try and solve for the area inside this pressure volume loop. So what's done is that this estimate is used, mean arterial pressure times stroke volume. And so let's look at the flow volume loop and see if we can figure out where those places are. Okay, so stroke volume. Okay, again, it would be the distance from here to here, would be the stroke volume, because this is end systolic volume, and then this is end diastolic volume. And again, we're always talking about the left ventricle. Okay, sometimes you just got to remember that. And so you're multiplying the stroke volume by the mean arterial pressure. Okay, where's the mean arterial pressure on the flow volume loop or the pressure volume loop? If you remember, this is pretty much considered diastolic pressure, the top of systole. So again, this diagram isn't perfect, but it's going to kind of go like that. So the top here is going to be, that's going to be systolic pressure. And then if you remember, because of the way the heart beats, the heart kind of beats like this. It goes like that. And so most of the time, it's spent closer to the diastolic pressure than the systolic pressure. And so the formula to come up with mean arterial pressure is going to be 1/3 of the way up. So we go up 1/3 of the way here. And so let's just say that's about 1/3. So that would be the mean arterial pressure. That's supposed to be 1/3 above diastolic. So, and actually I should have mentioned this too. What's the distance between here and here called? It's called pulse pressure. Okay, so it's 1/3 pulse pressure plus the diastolic pressure. And you can think of diastolic pressure as being like the baseline pressure when the heart is not contracting. So the only reason for this box next to it is to kind of illustrate what that actual estimate would be. So if we took the stroke volume and we put it on the x-axis, and then if we took the mean arterial pressure and we put it on the y-axis, then this is the actual volume that we're estimating to be this right here. So you can see they're pretty close. So anyway, so I hope that makes sense. Let me just say a little bit more about work, because I know it's a complicated concept. Work is the act of putting energy into molecules. So right here, we're doing work when the valve opens, because the blood is being ejected, so the force, the work is being put into the blood, which is now going to move through the body. So anyway, one other thing, this area down here, if I was to ask you what this is here, what kind of work would that be? That has to be work because we have something moving. So the left ventricle is being filled from here to here, but there's no contraction. And so this is actually passive work. It's the passive work of filling, whereas this volume here would be the stroke work. So I hope that makes sense. And this is the estimate once again. I hope that all makes sense, and hopefully if there's a test question on it, you get it right.